Okay, everybody, thanks for joining. We'll get started because today's lab will be brief. However, based on some of the responses from the lab from 2 weeks ago, where we had to determine the winds and which way the storm is spinning, I'm afraid that I want to go over this lab in a little more detail. So, if you haven't already, please download the Lab 9 from Blackboard. And this is what you'll see, Lab 9, Mid-Latitude Cyclones. So I'll get started with the first few paragraphs here, kind of explaining what this lab is about, that giving you a little review that in the Northern Hemisphere, the winds swirl around a low pressure counterclockwise, which is what you see here. Here's the low pressure on the diagram on the right, and the winds are going to be swirling around it in a counterclockwise motion. So for this lab, we have to take everything we've learned from the air masses and fronts and pressure and wind direction and convergence and divergence and basically put it all together in one big lab. And so the points that you see here in terms of letters, there's a letter A over here, a letter B, C, going all the way down through G. We're going to ask questions as to which way the wind is blowing, among some other things. So we'll get to that in a bit. First, on the right, you see here how we need to label the cold front. And we know that a cold front is going to be the leading edge of the cold air. So on your lab, you could make a text box and write in cold front as to where the cold front is. Then you could take a text box and on top of the warm front, write warm front, and similarly occluded front. And then in the lab, using the little arrow features in Word, you would draw little arrows as to where the whatchamacallits are, as to where the wind barbs are, which I wanted to show you right now. So I have to close this. And then if I were to go to, I think it's drawings, references. Maybe it's home. Who remembers where the arrows are? Oh, here it is, shapes. There we go. So you would draw arrows as to which way the wind is blowing, like that. And then here the wind would be blowing like that. So remember, the wind is going counterclockwise in this way, and that part B would be where the wind is, which way the wind is blowing. The Coriolis force, it just means that the wind never crosses over these lines of equal pressure or these isobars. So you would continue drawing in some winds there. Then finally, it says label the sectors most likely experiencing precipitation with the word precipitation. Well, we know that front of a cold front, where there's very warm air, it's hard to see here, but you'll probably be able to see it better on your computers. This area that's all drawn out is actually clouds. You can kind of see the clouds around the low. See that difference between the white and then the gray? And then you go down this way, and there's clouds over here to the right, and then over here where it says cold air, this is clear sky. So obviously you need clouds in order to have rain. So it's an easy indication, at least in some respects, as to where the rain would be. And we know that as a cold front pushes through the warmer air, which is labeled over here, that colder air is going to dig down and create some storms in front of it, in front of the cold front. So our rain would most likely be on the eastern side or the right side of this cold front over here. Where else would you also find some rain? Typically along the warm front, especially in this area ahead of the warm front, there's usually some rain. So those are two areas where you typically find precipitation in a mid-latitude cyclone. And then, let's see, how can I show you this? Okay, let's do this. Close that. All right. So some questions here on the right are these winds in the sun, number one. I'm up here on the top right, number one, questions for discussion. Are they converging or diverging? Well, we know that converging means that the winds are coming together, and diverging means that they're going out in different directions, like they're dissipating. So with the converging winds, because the winds are being kind of sucked into the low pressure, hence the low pressure here at the surface, these winds are coming together. So that would be able to help you answer this question. Circle or I guess underline, just make it obvious when you submit the lab. And then the air in the center of the storm, is it subsiding? Meaning, is it going down? Or is it rising? Is it going up? Well, if the storm centers here, the low pressure at the surface, how is a low pressure formed at the surface? The air is escaping, going up to the levels of the atmosphere, to the upper air. And so if the storm center is here at the surface, that L, and all of the winds are leaving it, escaping, going up, forming the low pressure at the surface, that's how we know that that is rising. Any questions so far before we go to the big grid? Feel free to interrupt. Then number three. Who's that? All right, number three is in the mid-latitude cyclone. Latitude cyclone moves eastward, which is this whole system here, the diagram on the left. Describe the weather elements at each point by filling in the table below. So let's do a few of them. By a poll, which one would you like me to see? Which one would you like me to do? A, B, C, D, E, F, G. Your pick. All right, let's do A. So here's the example of A is right there in the cool air sector ahead of the front. Looks like there's some clouds nearby, but not necessarily. So we know that is it either warm or cold? Well, we could put cool. I'll just add or cool. We'll add cool. Pressure of this is going to be determined by where we are in terms of the isobars. So here we have the 996, which is the ring around the low pressure. And then remember how every 4 millibars you can draw an isobar. So then 996 plus 4, we get 1,000. And then we get 1,004. And then 1,008. So if we follow 1,008 all the way around with my mouse to here, notice we come really close to the A. So just like when we were doing the isotherms and determining the temperature when we drew those maps in lab at the beginning of the semester, because A is in between 1008 and 1012, we can determine that A is going to be halfway between 1008 and 1012. And so the answer here would be 1010. And then we want to know if the air is dry or if it's moist. Well, let's take a look at the air mass. So here the A is near the cool air label, and we know it's on the cooler, drier side of the front. So if continental means determines humidity, and tropical determines the air mass, polar determines the, I'm looking at the other one, polar determines how cool it is, we know that this is a dry air mass because the maritime would mean it would have to be moist or humid. So because it's continental, we know it's dry. Remember, maritime, like this one down here where it says warm air, MT, the maritime would mean it would be moist, and the T for tropical would mean it's warm. Then we want to know the chance of precipitation. So this doesn't necessarily mean is it raining right now, but because we know that the storm is moving in this northeast or east-northeasterly direction, you see storm movement and the arrow right here, we know that there's clouds in this area of white around the warm front, and this warm front is moving closer to the letter A. So the chance that it's going to rain shortly is high because there's rain moving in. And then finally, the wind direction. Well, notice all of the wind arrows that I put in back here behind this cold front. The wind always moves parallel to the lines of equal pressure, or the isobars, and they go counterclockwise. So here, their winds are coming from the west, because remember, we always talk about wind as the direction the wind is coming from. And here, the wind is coming from the south, because even though the arrow is pointing north, if you were to stand right here where my mouse is, the wind would be coming from the south. So similarly, if I were to draw the wind for the point A, shapes, arrows, the wind would be coming from the south because it's blowing counterclockwise around the low pressure system. So for here, wind direction, we would write south. Okay, and then after you complete these, A through G, number 4 says, notice on the diagram near the low pressure center, as the occluded front formed, where the cold front has taken over the warm front. And it asks, what happens to the air mass in this type of front? And why is there a good chance of precipitation with this type of front? And that's it, just 2 pages. So if anybody has any questions, feel free to reach out. I'll be here. Or if you have any questions on any other labs that you'd like me to go over, let me know. And I'd be happy to do that.
I'm sorry, I was a little late, so I didn't really get the first part.
Sure. So the first part, yeah, Jason, I'll go over the precip again in a minute. On this one here, on the diagram ABC?
Yes.
Okay. So what we have here on the left is a picture of a mid-latitude cyclone. So basically, it's the low pressure system indicated by the letter L. And then we have the occluded front and the cold front down here and the warm front here on the right. And then all the air masses are labeled. So it says cold air, warm air, and then cool air up here. So what it wants you to do is just make a text box on top of the diagram. So I can do insert text box. Simple or draw. Here we go. And so here I will write cold front. And then you're going to do that for each of the fronts that you see here, the occluded and the warm. Then part B is to draw the arrows showing the surface wind directions at each point. So what it's asking is to take the shapes and arrows, and because we know that wind circulates counterclockwise around a low pressure system, these arrows are going to be drawn in a counterclockwise motion, always parallel to the isobars, because that's the way wind blows around a low pressure system. So you would go like this, and then it'd be like that. So all the wind is going to be blowing in a counterclockwise motion for part B. And then C is label the sectors most likely to experience precipitation with the word precipitation. So if you can just barely make out, you see that there's clouds here along these fronts. So this grayish area that's textured would be the ground or clear sky, and then this grayish whitish area are all the clouds. So this is where the precip would be found, because you have the cold air in the cold front digging down underneath the warm air, and that's making some thunderstorms here along the front. So you'd find precip here along the front, the cold front. And then also you see the clouds here on the right along the warm front. So obviously in order to have rain, you'd need clouds, and these clouds would be along this front showing where the rain is. So almost everywhere you'd see clouds, there would be rain, except all the way out here. You wouldn't have rain this far up north. But along the clouds here, along the front, you would have precip here along the warm front. And then there's going to be rain around the low pressure system center, where it's indicated by the letter L. And that plays into Jason's question about whether the chance of precip is high or low, because we know the storm is moving, indicated by this arrow, where it says storm movement, from the left to the right, in a sense, or southwest to northeast. And so with these clouds and rain that's moving from the left to the right, we could see that there's definitely rain coming toward letter B, definitely rain coming toward letter A, probably rain coming toward letter C, because even though there's no clouds over letter C, you have these storms that are along the cold front. They're going to move in shortly, so we could say there's a high chance of rain. It's definitely raining over point D, because it's probably thunderstorming over point D right there. And then back here, point E, well, all the rain is past, so that would be a low chance of rain. Did I answer your question, Kira?
Yes, thank you.
You bet. Anybody else have any questions? All right, so if anybody wants to chime in or needs help, I'll be here right through the end of the lecture or the lab, and so feel free to reach out. Does anybody want to break up into groups? Yes, Johanny. All right. Johanny, who would you like to be in your group? Brianna? Johanny. All right, making them right now. No, Sarah, you don't necessarily have to work in a group, but it does make it easier because it goes faster and you kind of learn from each other. That's, typically how labs work when you have a lab partner.
Even though point B is like on the cool air side, but it's on the warm front,
Yeah,
what
it's
would that?
along the front, but the warm front hasn't passed over point B yet. So the warm front passed over points C and D. It's kind of, I know, it's very close and it looks like a trick question, but it's technically on the cooler side of the warm front.
Professor, I have a question about the wind direction for
Sure.
point C.
Yes.
Yeah, the point for point C, would it be coming west or would it be south?
That would be, to be honest, a west, because you have
Okay,
to
okay,
include those. Yeah, there's consider 8 wind directions.
okay, got it. Thank
I'm
you.
making your um, group right now, Jennifer.
Thank you.
Okay, group 1, I have 4 people: Brianna Francis, Jason, Shailene, Yohani. Kabir is not in the group because she's not logged in. And then group 2, Jennifer, Heidi, Shelley. Is that right? Any changes before I submit it? I think you're allowed to change as well if you need to drop out for any reason. Correct. All right, cool. I'll be here if you have to, if you need help, or you can always invite me in.
point B be dry as well because it's on the cool side, or would it be moist because the clouds and the warm front?
For what letter?
B.
B. For B, I would say you're asking for a cool versus warm or dry? Oh, the
Dry,
moisture.
dry and
Dry
humid.
versus
Yeah.
humid. Well, B is on the continental polar side, and because continental means versus maritime, continental is dry, maritime is humid. I would go dry because it's continental.
Okay. Thank you.
Mm-hmm.
Are the last two described in our PowerPoint?
Hey, what's up? You said about the PowerPoint?
Yeah, are the last two questions described in our PowerPoint?
That would be, notice on the diagram with low pressure center included from forming the cold front taking over front. That would be the fronts. There is a look at the fronts PowerPoint, and on the fronts, the air masses and fronts PowerPoint, that should give you the answer. Okay.
Yeah, thank you.
You bet. Hey, Nakira, this should answer your question. On slide 22, the part C, look at what the warm where the warm air mass is.
Yeah,
You
I
see
just
how
seen
it's lifted
that.
up? You found it? Okay,
Yeah.
cool.
Thank you.
You bet.
Would you say the air is rising?
Yes, the air is rising because it's a low pressure pressure, and in order for the pressure at the surface to be low, the air has to be escaping, going somewhere, so it's rising up to the upper atmosphere.
Thank you. Have a good weekend.
You too. Take care. See you Tuesday. Hey, Shelly, what's up? How do we do this? Group 2.